In section 15.6, we go over cylindrical and spherical coordinates. So first, let's discuss cylindrical coordinates. So when dealing with triple integrals, and the solid region Q is bounded by, say, paraboloids, cylinders, or cones, typically it's going to be useful to calculate using cylindrical coordinates. So we've already discussed polar coordinates previously, and so cylindrical coordinates is essentially just polar coordinates in the xy plane together with the z coordinate. Right, so in this diagram here, it's describing how a point is described in three-dimensional space using cylindrical coordinates. So notice that the angle theta is playing the same role as polar coordinates in the xy plane. The parameter r is the distance in the xy plane from the origin out to this point here, and then the z coordinate is just the height. Okay, so that's the basic description for cylindrical coordinates. And so when we do a change of variables from rectangular to cylindrical coordinates, so again, you can see these formulas are the same as from polar coordinates. So x is equal to r cosine theta, y equals r sine theta, and x squared plus y squared equals r squared, right? Because again, basically in the xy plane, this is exactly just polar coordinates. So now, because we're working with triple integrals, dv, there's the parameters for dz, dr, and d theta. And just like in polar coordinates, there's this extra r that you have to include in the integral. So basically, again, when you want to write down a triple integral in polar coordinates, so you first identify how to describe the region in terms of the parameters theta, r, and z. And when it comes time to set up the integral, you make the substitution. So x is equal to r cosine theta, y equals r sine theta, and then the z coordinate is just the z coordinate. And again, the dv, you have to include this extra factor. You have to multiply by this extra r here before integrating. Okay, so that's the basic setup for cylindrical coordinates. So next, let's take a look at an example where we do such a calculation.